Okay, today it's a review video where we're getting ready for the final. And you guys have already had every single topic gone over briefly in class. Now it's a questions time. And the question I was asked was, how do you find those linear inequalities where they're like y is less than or equal to negative x plus 25? Well, I had everybody type that into your calculator before I started the video. But I just said type in equals that. Now, if I had said less than, do you get that that means shade underneath that line? Okay, and usually we have these two constraints. Y has to be bigger than or equal to 0, which is called a common sense constraint because you can't make negative widgets, so you got to stay above 0. And then you have x is less than or equal to 0, and that's this line. Sorry, greater than or equal to 0, sorry. And that makes you stay on this side of that line. So my question is, if you're staying above this line, to the right of that line, and below the red line, this feasible region right here is the important area. Everybody knows that's 0, 0. My question is, what's that spot? And what's that spot? I'm going to pause for a second while you try that. Okay, Mr. A, J, tell me how I can find one of these two. That or that. The y-intercept's in the equation. Very good. Another way to say it, though, is this y-intercept is where, finish the sentence. The y-intercept is where, kind of. Y-intercept is where x equals 0. I want you all to repeat that after me. Y-intercept is where x equals 0. That's really important, and that's a huge thing in honors pre-calc or pre-calc, whichever one you're going to. And the x-intercept is where what? Y equals 0. Okay, so for this one, which is the y-intercept, it's where x equals 0, and see, look, y equals 25. That's where they intersect. It's 0, 25. And this spot right here, that's the x-intercept, so it's what? Y equals 0. So then the 0 goes over here. Oops, let me just get rid of that then. And it's y equals 0 goes right there. And then what does that have to be? 25. And therefore this must be 25, comma, 0. And I knew it would be 0 because the x-intercept is where y equals 0. There we go. There's the 2 points. Now what if we had another line that was higher than this, but steeper going down, and then they would cross, right? I'm going to give you that line. It's y equals negative 2x plus 30. I'd like you to see where those two lines cross. That's a good typical higher algebra question. Got two equations. This equation, the red one, and this black one. And where do they cross? You can use your calculator for this one, so I'll pause for a second and give that a try. Okay, once you typed in this equation and this equation, I would use my calculator's second calculate, which is right above trace, and then I'd do the intersect option. And then I'd hit enter, 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 and it'll tell you where they cross. What did you get, Mr. NC? Where they cross. Not the y-intercept, where those two lines cross. Did you do that yet or not? Okay, try that. Second calculate intersect. What'd you get?
5, 20.
Anybody verify 5, comma 20? All right, now if my life depended on it and I didn't have a calculator, you know how I would check these? I would go stick 520 into both equations and see if it worked. Here's a 5, here's a 20. Does it actually work? 20 is equal to negative 5 plus 25. Yeah, that works. And let's try sticking in x is 5 and y is 20 over here. Does it actually work? 20 equals 2 times, negative 2 times 5 is negative 10 plus 30 negative. And that makes positive 20. And yeah, that works too. That point works in both of them. Therefore, it's the solution to the system of equations. All right. Now, somebody else asked me about optimizing. If the optimization equation was based on this, see if you can write it. By the way, it's always If it's for profit, you say P equals. If it's for cost, you say C equals. I'm going to do a profit one. So P equals, and you figure out what to write. I make 20 bucks for selling an X. I make 5 bucks when I sell a Y. What's the optimization equation? Yes, sir. P equals 20 for each X plus 5 for each Y. Perfect. Then, of the points where these cross, which one makes me the most money? 5 comma 20, 0 comma 25, or 25 comma 0? Sir. Oh, good catch. If this is shaded, we have to assume this is shaded underneath this. That is not a point in the feasible region. Good catch. And that happened on one of our tests where they asked you to see where would the most be, and a lot of people picked the wrong spot. It wasn't in the feasible region. Here's the feasible region now. So maybe that point would be important. It's called the x-intercept, so it's where y equals 0. So you'd stick in y equals 0 into not the red equation, but the black equation. If I stick in y equals 0 in there and solve it, I can figure out that I'm going to subtract 30 from both sides. Negative 30 equals negative 2x, so x equals 15. So this point right here is the third feasible region point, and that is 15 comma 0. So what makes you the most money? 15 comma 0, a whole bunch of x and not much y. Think about it. X makes you a fair amount of money. You get 20 bucks for each x. So that's probably a good one. That's probably one of the contenders. Or this spot where it's only 5 x's but 20 y's. Or this spot which doesn't have any x's but a bunch of y's. I probably would have checked all 3 of those. Well, this one's the simplest. It's only got y. So I stick that into my profit equation. 0 and 25 go here. 0 and 25. So basically it comes out to 0 x's, so no money for those, plus 25 times y makes 5 times 2 is 10, 25, 200 and what? 5 times 25 isn't that 125? Pretty sure this is 125 right here. Anybody verify that? Okay, good. Then the next one's 5 comma 20. If I put in 5 here and 20 here, you're telling me I get 175? Yep. I don't think so. I think you get 200. It's 5 times 20, which is 100, and 5 times 20, which is 100. And so that's 200. So far I got 100 and a quarter, or 200. Well, obviously 200 is better than 1 and a quarter. And the last is 15 comma 0. That goes in here where this is a 15, and that's a 0. 15 and 0. 20 times 15, ooh, that's going to be pretty good. That's more than 200. 20 times 10 would be 200. It's 300, right? So, moral of the story, we calculated them all up, and this one definitely has the most profit. Basically, it makes sense because we have the most of these x's where we make 20 bucks each, and we don't have much on the y side, but they only made us 5 bucks each anyways. All right, so there's a topic, and we've kind of re-gone over, and it will be one of the harder ones in the test. So what else that confused you on this packet? We can go over those type of problems. I'm going to make up like 10 more minutes worth of questions, so might as well be yours. Yes?
Well, I don't know if I got that one. I looked at I got the one for the inverse of matrix. I actually got
Maybe there's a mistake on the key. All right. So there was a question about inverse of a matrix. Which problem number was it? Do you remember? Problem 6. All right. Would you read me problem 6? Because they think there's a mistake on the key, so I better do it. And if my answer comes up different than the key, we'll be suspicious. Read it to me.
negative 6x minus 2y minus e equals negative 16. 5x plus y minus 6b.
Minus what?
6b
Okay.
equals 19.
And then?
Negative 4x minus 6y minus 6 equals negative 1.
And they want you to solve this using matrices, I'm guessing. Okay. Here's your matrix equation. Negative 6, negative 2, negative 1. 5, 1, negative 6. You get, I'm getting all of these from the little numbers in front, the coefficients. There we go. And then now it's negative 4, negative 6, negative 6. Did you agree with me so far? Okay. Then you should have had x, y, and z. And then you should have had the other matrix, which is a simple answer matrix with negative 17, or positive 19, and negative 20. With me still? And I'm guessing the key is probably wrong, but we'll see. This says is A, and this is B. And so if you're going to do this on a calculator, you need to get rid of this one. So how do I get rid of that? By multiplying it by the inverse of A. And if I do it to the left side, I got to do it to the right side. And you got to keep it in order where the inverse is on the left side of the other. So this one times this one makes it cancel. And x, y, z equals inverse of matrix A times it by B.
The key was right. Yeah.
Okay, the key was okay. All right. Must have typed in one. All it takes is one number being wrong in your matrix and it didn't work. All right. To do that, once you're in the matrix part of the calculator, you would then get the A on the screen, and then you want to type the A matrix to the negative 1 on the calculator, and then times it by the B matrix, and you just hit enter. Okay, yes. CC over C question, sure. All right, so this would be probability, and remember, if it's CC over C, it's probability. What if it was just how many ways can you? What part don't you need then? The bottom part, the over C part, won't be there. All right, so let's do one of each kind. So let's say that we have a deck of cards. That's a very typical question. So remember, during the test, you can always ask me, like, how many hearts are there in the deck or whatever, and I'll tell you. Because I know some of you guys are good at cards and some of you never play cards. So here's a typical question. First of all, just a number of ways. How many different ways could I deal you 3 cards where you'd get 2 aces and a king? There's a bunch of different hands that have 2 aces and a king. My question is, how many are there? So this is a CC question. Not CC over C, because that would be probability. Well, if you know it's CC, half the battle's already done, because now you know it's got to be some number possible, and then this is how many you want. And some number possible, and this is how many you want. So if I wanted 2 aces, these will be aces, and these will be kings. And if you're really smart, you do the others too. Now, you don't have to do that in this case, but it would be handy to know that, because we like to throw questions at you where it's like, you're drawing 5 cards. What's the probability 2 will be aces? Well, that forces you to think, so 3 of them must be other cards. Anyway, so how many aces are there? 4. How many do we want? 2. How many kings are there? 4. How many do we want? And now, does this represent our totals, where we have a total of 3 cards being dealt to you? Yeah. So there we go. We're done. So why did I say we needed this other C? Because there were a total of 52 cards. Then you take out 8, and that leaves you like 44, I think. Is that right? And then you want 0 of those. Why do we do that? Just because then we'll have a total of 52 cards we picked from, and then a total of 3 that actually come out of the deck. Those all add up to 3. All right, now here's a probability CC over C kind of question. I'm going to deal you 5 cards, actually 7 cards. Have you heard of 7-card stud? It's a poker game where you get 7 cards and that's it. You don't get any extra cards. You don't get to turn anything in or anything. It's just you've got 7 cards. And then in the real poker game, you choose your best 5 and you play that hand. Okay? So I'm going to deal you 7 cards. What's the probability you're going to get all 4 aces? which would be a fantastic hand to have gotten. What's the probability you're going to get 4 aces? Notice I didn't say 4 out of 4 cards. It's 7 cards you're being dealt. What's the probability you're going to get all 4 aces? I did say probability, so yep, it's CC over C. So I encouraged you to start with the denominator on this kind. That's the kind where these are the totals. And there's 52 cards in the deck, and you're being dealt 7. That's why those numbers are the biggest numbers you have. Then subgroups on the top, and this is aces. And there's 4 aces, and you want to get all 4. Then what's the other thing? Can I just stop right here? Because that's all I ever said. No, you can't stop there. Let me show you why. This plus this is supposed to add up to this, and right now it doesn't. So what should I put there? 48. 48 other things besides aces, and I want how many of those? 3. Now do my numbers balance? This plus this equals that, so that balances. And this plus this equals that, so that balances too. Whenever you got those balanced out, you probably have. How many of you had that right? Okay. That's right. That's a CC over C question. Next topic. Who's got one that they want to talk about? We got about 6 minutes left. Yes?
Can we do one where it gives you, like,
Okay.
Like, it gives you a number of things, and then it says how many ways you choose this number, and then it gives you, like, a follow-up that says, like,
So, like, let's say I have marbles in a bag.
Yeah.
Okay. All right. So let's say I have 3 blue marbles, and we'll have 2 green marbles, and we'll have 1 black marble. You reach into there and you grab one. How many different ways can you get sets of 2 marbles? Notice I didn't say probability. I said how many different ways can you get sets of 2? I didn't say what kinds. I just said 2 at a time. Did I ever say anything about the order? Like it had to be this and then that. So therefore, is this a P or a C? C, good. And how many are there? 6 marbles. And I'm taking out how many at a time? 6C2. Do you know a couple ways to do that? Calculator can do it. I hope you know how to do it with a calculator. Otherwise, option B, 6 factorial over 6 minus 2 is 4 factorial. And C, there's an extra 2. Does that ring a bell? Remember that? All right. This means 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. And that's this 4 factorial. And then the 2 factorial is 2 times 1. And then I can cancel off 4, 3, 2, 1, 4, 3, 2, 1. That's 30 divided by 2. So I know the answer is 15. Just about as fast as the calculator if you know what you're doing. Yes? Uh-huh. Okay, so this was just how many ways can we get, and it was 30 divided by 2 is 15. There's 15 different ways you can get sets of 2. Now we can definitely make it a probability. So now that I've changed it to the problem from the packet to be 3 blues, 2 greens, and a black, my question to you is, what's the probability that if I reach in here and grab 3 marbles out, that I will get the black one? Probability, right away you know it's a fraction. If I grab 3 marbles, what's the probability I will get the black one? How many of you knew to do CC over C? Good. Where do I usually tell you to start? Bottom. And there's how many total? 6, and I want to pull out how many? 3 marbles. Then I go to the top and I start doing subgroups. What was I talking about? Like pretty ones versus not pretty ones, or boys versus girls? No. Black ones versus not black. How many black ones are there? 1. How many not black ones are there? Wait a minute, wait. One thing at a time. How many of the black ones do we want? 1. Times, how many not black ones are there? And how many not black ones do we want? Not 4. 2. Because this plus this has to add up to this. And that plus that has to add up to that. And looks like it adds up. So I think it's right. Any questions about that one? Okay. It gives you 3 what? 3 things? I did have 3 things. I had black, blue, and green.
No, I'm saying, like if it gives you red, blue, and white, then you just add another C.
Oh, okay. So you want 1 black, 1 red, 1 white, that kind of thing? Okay.
Yeah.
So let's say that the question was, I'll make the one like that. What's the probability that you reach in here and you get 3 marbles and you get 1 blue one, 1 black one, and 1 green one? Then you need 3 C's, just like you said, because there's 3 requirements all over the total. See if you can set that one up right. Try it. Probability you get 1 of each when you reach in and grab 3. There were 3 blue ones and you want 1. There's 2 green ones and you want 1. There's 1 black one and you want 1. And it adds up to 6 of them and you want 3 of them. And does this actually add up? 3 plus 2 plus 1 makes 6. And 1 plus 1 plus 1 makes 3. Yay, there it is. Okay, next topic. Still got a couple minutes left. Yes?
You have a deck of 52 cards.
Yep.
You draw 2, but don't replace.
When you're not replacing, I would be thinking fractions. And then the first one that you draw out of your 52 cards, you got to figure out the probability of that first one the old-fashioned, the simple way. It's out of 52 cards. And how many were there that you wanted? Like in this case, was it red cards, black cards,
The
or?
first card draws red, and the second card is a club.
Okay, so this is red, and this is club. All right, then red, I'll do this one, I'll have you do another one like it. The red ones, there are 13 red ones. No, wait, there's a lot more red ones. There's 26 red ones. There we go. Now for the club, remember, we have to assume he got the red one, because that's what we were doing, is he got that red one. So now is, how many cards are in there now? 51. And this is important, how many clubs are in there? Still 13. Because even though we got a card, we're assuming we got a red card. So there you go. That's how you'd multiply that one up. Yes?
So I did that, but it gave me a different answer.
Oh, interesting. Okay. So you might, the key might have a mistake on this one. Which problem number is it?
39.
Problem number 39. I will ask about that. What did you get when you multiplied 26 times 13 and divided by 52 times 51?
0.127.
Can anybody verify that they got 0.127? Is it verifying? Okay, good. All right. I believe that is the correct answer. So I will tell the person who made the key that there might be a mistake. Maybe there's some good reason it's the other way. Anybody tell? Oh, is that the answer that's in the key? Oh, well, there we go. I guess I won't have to worry about telling the person who made the key. Okay, it's all right, it happens. So, are there any other topics you'd like to talk about? So, we're down to the last 12 minutes or so. I'm going to let this be individual help time. I strongly recommend that you study not just this packet, but any topic that you know you're weak on. Like if you're good at probability, then don't study probability. Take this last chance to study take stuff, I know this isn't fun, but take the stuff you're not good at and do that. Because you want to like make sure if you're only going to get 50% on one little section, you can boost it up to like 80% by some studying. That'd be really smart. If studying stuff you're already good at doesn't really help because you're already good at that. All right. That's all I have for the video for today, and good luck to all those taking the final.